Hello everyone, welcome to our channel. In this lesson, let's take a look at how this liquid filling and capping equipment works. There are two focuses for this lesson. What is the specific workflow of this equipment? And what is the overall structure of this equipment? Now let's take a look at this equipment together. First of all, we want this container to be conveyed to feed in, and then it can be filled and sealed. The occasions in which we need this equipment are many, for example, the mineral water that we usually drink and also the kind of syrup that we usually drink when we are sick. And the shampoo, shower cream that we usually use daily, all require this filling and capping equipment to achieve the filling and sealing needed. Let's take a look. So here we need a power source, that is, this piece of ordinary three-phase asynchronous motor. The front of it is connected to a worm gear reducer. In fact, the two of them should be called RV reducer together, but here we call it separate in two parts. So here is the output shaft of our reducer. What we are connected with is the sprocket wheel of the belt chain, then here it can drive the sprocket wheel, further driving the chain belt, achieving the purpose of conveying. So now let's take a look at this position. We use this kind of mounted bearing, which makes the chain belt movement smoother. Then this position, the whole rack adopts this kind of bending sheet metal, and here wear resistant nylon is adopted. Because here if you don't use this wear resistant nylon, it will be in direct contact with sheet metal which may cause wearness to the chain belt. So a layer of wear-resistant strip is usually laid here for avoiding wearing. The strip is easily purchasable in e-shops. The use of this guardrail is actually equivalent to standardizing the transporting path of a container. If you don't use the guardrail, it may deviate from the required path needed for operations. So here the guardrail serves the purpose of both protecting the bottle and guide the transporting path of it. Let's take a look. So, this chain conveyor is the one that we use to transport the bottles. They started at this position, onto this chain conveyor and being conied in the middle of rails. And when they reach this position, there are three cylinders. Where are the three? First of all, the first cylinder is in this position. Here there is a pen-shaped cylinder and below it is a guide shaft. And at the front of them there is a small sheet metal, which will block the bottle when the cylinder extends. Here's question. Here why this kind of chain conveyor is used? Because the surface of it is very smooth, which reduces the wearness to the bottle. Bottom. If the surface is rough, it will have a lot of wear and tear on the bottle bottom. So here we use the chain belt for smooth transition of the bottles even when the bottle is blocked. Now here we have another pen-shaped cylinder, and on the sides of it, there are two shafts. They are also connected to such a sheet metal part, but it has 1 2 3 4, totally 4 heads for positioning the bottles. When the bottles being conveyed here constantly, this mechanism will grasp the bottleneck of 4 of them for filling operation. Here is another cylinder which is connected to this rod whose upwards and downwards movement will auto-opens the fill heads for filling. When the filling, which is metered by either volumetric or timing, is completed. At this time, the cylinder here which is a little bit smaller will retract to release the bottlenecks. And only then, the cylinder here will retract to let go the filled bottles. Here is another question, how do we know when to let in another 4 unfilled bottles for filling? Here this position we have a sensor for sensing the required number of bottles. When 4 bottles are sensed, it will control the extending and retracting of the cylinder to release and block bottles. Here the bottle is conveyed and the guide rails to slightly bend to guide the bottles into this intermittent mechanism. This mechanism, due to the stations here are only 5, so we do not adopt the cam splitter, but a simpler Geneva wheel driven by a motor. And this mechanism rotates a certain angle at a certain time to transport bottles. Here are the 5 stations, only one station is not used. The bottle is held here, and the second station, the caps will be fed and placed. And there is the bowl where we dump the caps. At the bottom of it, there is a motor, driving the star wheel. Here is a question: when the caps are dumped there, it may be either orientated this way, or upsides down. So how to orientate all the caps in the same direction? Here the air blowing principle is adopted. Here there is throttle valve where compressed air can be connected in. If the cap sits this way, it will be blown upside down, and if it sits this way, it will remain the same rather than be blown to flip over. And when it is being vibrated to this position, here the chute will orientate them unanimously in the direction. And later they will be placed by this mechanism onto the bottlenecks. And here the air motor and the up-down cylinder will auto-tighten the caps onto bottlenecks. So here is this lesson, explaining the structure and workflow for the liquid filling capping machine. If you have any questions, subscribe and leave a comment below. Thanks for your listening. See you next time.